I welcome you all in this session of Artificial Intelligence Essentials. I thanks to TDRA for giving us the opportunity to deliver this session. First of all, I will introduce you with myself. I'm Tariq Khan, a professional trainer. I have more than 14 years of experience in different diverse organizations, information technology, information security, cybersecurity, networks, telecommunication, and I have done MS in telecommunication and networks, BS in computer sciences. I am a certified AC code instructor. I am also a certified ethical hacker. I'm CCNA CyberOps. I have done CCNA. I have done ITLV3. I have also done IBM cybersecurity analyst specialization. And then I have done IBM AI Essentials training and certification. So now we will discuss about the expected accomplishments of this course. So the first is learn how we can make the computer intelligent using machine learning. Then you will learn and accomplish after the course and understand the concept behind deep learning and how it can help us in smart city concept. Then we will understand the difference between normal algorithms and intelligence algorithms. Then we will understand how can computer take decisions on behalf of the human being using artificial intelligence. Now we will discuss about the table of contents. First of all, there is an introduction to artificial intelligence. Then we will understand AI and machine learning and deep learning. Then we will discuss about the applications of AI. Then we will discuss about machine learning. Then we will discuss about machine learning applications, then deep learning, and then deep learning applications. And then the last session will be question answer session. So first of all, I want to introduce you with the AI. Basically, AI is the science of engineering for making intelligent machines. There are different definitions of artificial intelligence. Okay, so we will discuss. Artificial intelligence is the technique of getting machine work and behave like humans. This means that we are inducing uh, intelligence to the machine, so they will behave similar to human beings. How human thinks, how human make decisions after analyzing the things. So uh, then artificial intelligence is a simulation of human intelligence process by machine, especially computer systems. Then specific application of AI include expert systems, natural language processing, speech recognition, and machine vision. And there are other as well. So first of all, we should know what is the difference between AI, machine learning, and deep learning. Artificial intelligence is the concept of creating smart, intelligent machines. So machine learning is a subset of artificial intelligence that helps you build AI-driven applications. Then deep learning is a subset of machine learning that uses a vast volume of data and complex algorithms to train the model. Here, you see, the artificial is a big picture. Okay, AI concept is used and enables computers to mimic human intelligence using logic, if then else rules, decision trees, and machine learning, including deep learning. So we have already discussed that machine learning is a subset of artificial intelligence, and deep learning is then the subset of machine learning. So as we know that technology is continuously evolving. So in 2017, KG, the world's best player of ancient Chinese board game Go, was defeated in the three-state games by AlphaGo, an AI computer programmed developed by Google which is called Google DeepMind. So at the time of 2016, it was expected that it cannot be happen, it cannot be possible. But After 1 year, this happens. Okay, so people and the most experts in the field of AI or in the field of science were expecting that it will take 5 to 10 years before computers would beat human Go champions. But technology is evolving so fast. So this happened after 1 year. Then enterprises have unsurprisingly lead AI adoption growing by 270% over the past 4 years. And we have the reference which is taken is timelyapp.com. And AI is not only for industry giants done. A ton of new AI application offer companies unprecedented competitive advantage without requiring infrastructure for. So we will now discuss some applications of AI. Like AI is used in navigation, like in optimal for finding optimal path during the driving. We have many application which we are using from different application stores, like from Apple and also from the other stores. So and download it and we'll use it to find the optimal path towards the destination so that we will not face any time delay and any traffic. So GPS technology with the convolutional network, neural network, and graph neural network give us this opportunity to use these type of applications. Then we have AI is used in robotics, like here, Sophia, a very you know big what we call invention in robotics. Sophia acts like humans, so that's why it's called humanoid robot. So it feels and then response is like humans. So and also Sophia have been given the nationality of Kingdom of Saudi Arabia. This is the first robot who have ever achieved this nationality because of this great invention. Then we have other humanoid robots like Gia, Sophia, Rika, uh, Nadine, and Junko Chira. So these are all, the robots which are acting like humans and their expressions and so on. Then we have the robots which are working in industries and providing the services to the customers. Like here, if you see the robots are working in some departmental store, so they are arranging the things in the drawers. So AI in human resource, yes. Nowadays, HR is enjoying the sources of AI for reinventing onboarding process, for reshaping hiring process and revamp training process. And then AI helps in revitalize performance analysis. Then AI is also helping analyzing, understanding the employee problems. And there are other, supporting sources as well. Then we have AI in healthcare and yeah, supporting the doctors and the processes so that the doctors can easily predict the things based on the analysis of the AI softwares and applications. Then we have AI in agriculture, like uh, field condition management. AI is helping in soil health, water management, monitoring crops, and disease detection. Then there is a weed control. Then we have a water forecasting, weather forecasting, precision agriculture, and there are a lot of other applications of AI in agriculture. Then AI is used in gaming, and nowadays uh, there are the characters which are called NPCs, non-playing characters, which are not controlled by any player. They are controlled by itself by using the artificial intelligence and interact with the other players. Then we have AI in automobiles, like the great invention is self-driving car, deep learning, which is a branch of AI, the subset of AI is used in this self-driving car. Then AI is used in social media, like Twitter, Facebook, YouTube, LinkedIn. There are so many social media softwares are there in which AI is used, and those softwares are helping us. Then we will discuss some robotic application in business, like robot vehicles, delivery trucks, big trucks, shuttles. Then in the industry, we have welding robots, industrial cleaning robots, laser cutting robots. Then we have in construction, we have the brick laying robots, mobile drilling robots, transport robots. Then in security, we have security and surveillance robots. We have monitoring drones. We have search and rescue robots. So for entertainment, we have storefront robots, special effects robots in films, fantastical creature of robots, like we have discussed the humanoid robots. Then we have customer services. Robots are also used in customer services, like shopping assistants, promotional robots, tour guides. In logistics, robots are used for shelf management, storing robots are there. In agriculture, autonomous tractor are there. Weeding and pawning robots are there. In telepresence, we have remote monitoring, tele-education robots are there. Then we have in food processing, cooking robots, pizza making robots are there. So cake decorating robots are there. So there are now AI is emerging as a biggest revolution. I mean, it is a biggest revolution, and in our lives, in industry, in businesses, in every aspect of life, AI is involved. Now, AI in gaming. So, AI in gaming is all about creating more responsive, adaptive, and challenging games throughout the use of artificial intelligence, like monster hunting. Then AI is used as NPCs, as already discussed with you. Then NPCs can even learn from player behavior and adapt according to their tactics. Then pathfinding is here using the artificial intelligence. Uh, in game, players find the paths automatically. Then decision making, like here, for example, the player has it's a war game and player has ammunition. Then it will decide, as you can see over here, it will decide if it has this player has the ammunition, it will attack. If it don't have, it will see the cover is there, then it will defend. If no, it will run. So decision making is also there, and by virtue of AI. Then data mining is there. Then uh, procedural content generation. A lot of AI application in games. Then we have player experience modeling. So here you can see uh, the player, make the decisions and model and make the tactics by virtue of artificial intelligence. Then cheating concept is there in game. Although cheating is not good, but it is used in game because it's a game. So the types of games AI techniques are deterministic AI techniques and then non-deterministic AI techniques. The benefits and future of AI in games. The games become smarter and more realistic, save on cost and time, make it easier for the user to play, eliminates the predictability of the game. Future of AI in gaming is we can use cloud for gaming purpose. Then we have a blockchain-based gaming. Okay, and there are different varieties of games of blockchains. Then the voice or audio recognition-based games are there. Then we have a variable sport gaming and VR gaming, as you see in this picture. A person is wearing different appliances for playing the games. Then now we will discuss about the machine learning, because machine learning and deep learning is the main subset of artificial intelligence, or the point of the artificial part of the artificial intelligence, which is used for getting the aim of, or getting the result of AI. Machine learning is a type of artificial intelligence that allows software application to become more accurate at predicting outcomes without being explicitly programmed to do so. So, machine learning is a branch of artificial intelligence and computer science, and focus on the use of data and algorithms to imitate the way that the humans learn, gradually improving its accuracy. And machine learning, we provide the data to the algorithms, the model of machine learning, and machine learning then give us the results. Like here, uh, this ordinary system, with AI and machine learning, we predict the things, and we learn and we improve the things. So here we see machine learning algorithms use historical data as input and predict new output values. Traditionally, we have the set of rules. For example, there are different, here in example, there are different pictures of dog, bird, cat, fish. When we are feeding some system which will predict, for example, we already feed the data and we have the rules. And these rules then come when we, for example, we feed a new picture of a cat to this system, then it will run these rules and compare the previous pictures, and then it will decide whether the feeded picture is of dog, bird, cat, or fish. But the issue is that uh, we have, this is it's a generalized, and we have write too much programming. We have maybe thousands of lines of programming, more than that, for this. So this is when machine learning entered the scene. Using machine learning allows us to build a model that looks at all the feature sets and their corresponding types of animals, and it learns the pattern of each animal. Like here, uh, we provide the data set to the machine learning model, and then we will provide the sample, and then this machine learning model will learn itself by comparing, comparing and analyzing the features of already fed data with the labels. Labels mean that already we feed the data set of, for example, here different pictures of dog, bird, cat, and then we will uh, uh, first of all tell the model that this is a picture of cat, this is a picture of dog, and so on. Then we will, for example, we will feed a new picture of a specific cat, which is not already present in data set. Then this machine learning model will extract the feature of all the previous feeded pictures and then predict whether the feeded picture is of what type of cat, or what are the feeded picture is of dog, bird, cat, or fish. It is a model built by machine learning algorithms. Yeah. It detects without explicitly being programmed to do so. Examples of machine learning, for example, Netflix and Amazon recommended videos, movies, and TV shows to its users by using machine learning to produce suggestions that you might enjoy. Then, how do you think that banks make a decision when approving a loan application? They use machine learning to predict the probability of default for each applicant and then approve or refuse the application. And that is based on the probability. Then, machine learning is used in telecommunication companies for customers' demographic data to segment them and predict about the customer whether the customer will be retained or it will leave the this service provider next month or after some period. So, due to the virtue of machine learning, the companies are analyzing the customer's data and then uh, improve their processes and techniques so that they will retain the customers. Then there are many other applications of machine learning, like chatbots. We are using chatbots whenever we nowadays we are interacting to some business sites or to some service providers. There are the chatbots which are helping us initially, okay, uh, to resolve our issues. Then when we logging into our phones, and then computer gaming using face recognition. Each of these use different machine learning techniques and algorithms. Like first of all, we discuss regression or estimation technique. In this regression estimation technique is basically the predicting things like the price of house based on its characteristic, or to estimate the carbon dioxide emission from a car engine based on the car engine features. Uh, then classification technique is there. Classification technique is used to predicting the class or category of a case. Example is of a cell, for example, is a cancer cell, uh, whether it's benign or malignant, or whether or not a customer will churn. Uh, Clustering groups of similar cases, for example, find similar patients can be used for customer segmentation in the banking field. Here, for example, there are different categories of customer which was analyzed by the machine learning, like money hawks, emergents, traditionalists, offline loyalists. Then we have yes, there is a question that what about the AI in information technology? Yes, AI is involved in every aspect of information technology. As already I have discussed that we are using the applications uh, in a daily life, and daily like in mobile we have the different. We are using different applications, social uh, media applications like Facebook, like we are using WhatsApp and Skype, and there are different applications. Okay, we are using in business. We will discuss later on uh, about information technology uh, applications. We already discussed. Okay, these are also many applications are under IT information technology. So now we are discussing about the association technique. It is used for finding items or events that often co-occur. Example is grocery items that are usually bought together by a particular customer. For example, here, customer one bought a milk, bread, butter. Customer two brought milk, cereal, bread, butter, and customer three bought milk, bread, and butter. All three customers, they are purchased the things which are similar. So here we will associate these three customers having the similar purchasings. Then anomaly detection. For example, it is used to discover abnormal and unusual cases. Example is credit card fraud detection. Here, terminal check is there. Then predictive model will provide the fraud score. For example, anybody who use the card, then the investigator will provide the feedback about the card, and this feedback is used by the predictive model, and then uh, the decision is made whether to accept or reject this card. Then sequence mining. It is used for predicting the next event. For instance, the click stream in websites. Then we have a dimension reduction. It's used to reduce the size of our data. Then we have recommendation systems. This is basically dimension reduction. Okay. Here we have the random data, and then this due to this virtue of this dimension reduction, we have uh, reduced the redundant data, and we have now this data. Then we have recommendation systems. For example, recommending books or movies to customers. Here, for example, these two customers read both these books by these customers. They both read this, and then the recommended system uh, recommended the book or the article to this person, which is read by this lady. Then we have this is called collaborative filtering. Then we have content-based filtering. For example, here the reader read some article or book, and then recommender system will recommend the similar articles to this user. Then machine learning types. We have basically two types of machine learning: supervised learning and unsupervised learning. In supervised learning, we are feeding the data. For example, here we are there is a picture of Apple. This is only just for the assumption. We are feeding this data. For example, the apples, and then we are also telling that this sample is apple to a model. Okay, so then this model will, for example, we will feed a new type of picture of a fruit to this model. Then this model will predict where the on the basis of the previous data, and for analyzing the data and making the comparison of the features, then it will predict, and then it will give the result whether it is apple or not, or any other fruit. Then unsupervised learning is that when we input the data, we don't tell the model that about this data. We are not giving any label to this data. Based on the features of the input data, the model will predict itself whether the input data belong to some specified category. Like here, for example, we have apples, we have I think the speech, and then banana. We have different type of fruits. Then this model will categorize or classify or differentiate between the fruits and give us the result. Then we have supervised learning. Supervised learning is, yes, we already discussed. So we teach the model, then what knowledge it can predict unknown or future instances. Okay, we first of all teach the model, and then it when we give the new test data, it will predict based on the previous features. For example, here we have this cancer data set, and these are the attributes. Okay, and we have the this class benign or malignant. So we are giving the label. Okay, and based on that, it predicts the data about the new test data, whether it will be benign, malignant. So these are the features. For example, this is a clump and uniform size and uniform shape, and this is another feature. There are so many features are there. Okay, based on this value of this parameter. Okay, these are already fed data. When, for example, we feed the new data, then it will predict. Okay, This is the model. We are teaching with the model with the labeled data. Okay. So, for example, here we have this value of clump is 2, and but based on these parameters, then we can it can the system can predict whether the cell is benign or malignant. Then we have a classification technique, or we can say algorithm. Classification is the process of predicting by a discrete class, label, or category. For example, here we classification. We're making the classification of the two different data sets. And we have the classification process of predicting discrete class labels or categories. Okay. These are categorical values basically. So now we will learn about the classification algorithms in machine learning. There are different type of classification algorithms in machine learning. For example, decision trees, naive Bayes, linear discrimination algorithms, and k nearest neighbor, logistic regression, neural networks, sport vector machine, SVM. So we cannot go to discuss each and every algorithm, but this basically is an intermediate course. So we shall know about the algorithms which are used for classification or for the other techniques. Okay. Then regression is there. Regression is the process of predicting the continuous values as opposed to predicting a categorical value in classification. So we will look at this model. For example, we have this data. We have engine size, cylinders, fuel consumption, and then we have a CO2 emissions. Based on this, we have the data. Like engine, a specific car engine size is 2, cylinders 2, and then fuel consumption is 8.5, and its CO2 emission is 196. This is a value. Based on this already provided data or regression through regression, we can predict a new value. Okay, and this is called the continuous values. This is not categorical values. These are discrete values as compared to the classification. Okay. Given the data, we can use regression to predict the CO2 emission of a new car. Yes. So here we can predict the new CO2 emission of a new car. Like a new car, we have the model, then it will give the model will give us expected CO2 based on the historical data and its features. Then we have different types of regression models, like simple regression. In simple regression, we have a simple linear regression and simple non-linear regression. And here we predict CO2 emission with engine size. In a simple regression, we have, for example, one specific input value. Based on that input value, the system will predict the output value. Then we have multiple regression. In multiple regression, we have more than 2 input values. And based on that, the system will predict the output value. Then application of regression or sales forecasting, satisfaction analysis, price estimation, and employment income. These are the application of regression. Then the regression rhythms are ordinary regression, Poisson regression, fast forced quantile regression, linear polynomial layers to stepwise ridge regression, then Bayesian linear regression, neural network regression, decision forest regression, boosted decision tree regression, then KNN, K nearest neighbors. So as already discussed that we have these values which or the output are dependent variables, and these input data are the values of input data or the parameters are independent variables. Then we have unsupervised learning. In unsupervised learning, we are not adding any labels. Okay, and it means that unsupervised learning algorithms train on the data set and draws conclusion on unlabeled data. Generally speaking, unsupervised learning has more difficult algorithms than supervised learning, since we know little to no information about the data. We don't know about the data because we are not training the model about the data. It will predict the data based on the features. Okay. Then we have a dimensional reduction. It plays a large role in this by reducing redundant features to make classifier easier and remove the redundant data from the data set so that it will be easy to classify the data. Then we have market basket analysis. It is a modeling technique based on the theory that if you buy a certain group of items, you are most likely to buy the other group of items. Then we have density estimation. It is a very simple concept that is mostly used and explore the data to find some structure within it. Then clustering. It is the most important and popular unsupervised machine learning techniques used for grouping data points or objects that have some similar properties. Like here, there is a data set, and then we classify it, make the groups, different groups, using the cluster technique. The cluster analysis has many applications in different domains, whether it is a bank designed to segment its customer based on a certain characteristics, or helping an individual to organize in a group his or her favorite types of music. Then, generally speaking, although clustering is used mostly for discovering structure, summarization, and anomaly. Then, okay, these are the application of clustering, retail marketing, and in retail marketing for identifying buying patterns of customers, recommending new books for movie to new customers. Then banking sector, fraud detection in credit card use. Then clustering is used in identifying clusters of customers, whether they are loyal or not. Insurance and clustering is used for fraud detection in claims analysis. Then in ensuring risk of customers. Then in publication, auto categorize news based on their content, then recommending similar news articles to the customers, to the readers. Then in medicine, clustering is used for characterizing patient behavior. Then in biology, clustering is used for genetic markers to identify family ties. Then clustering algorithms are partition-based clustering, which have relatively efficient. An example of K means, K median, fuzzy C means. Then we have a radical clustering, produces trees of clusters. Density-based clustering, then produces RPD-shaped clustering. An example DB scan. Sorry. Then the difference between the supervised and unsupervised learning is that for supervised learning, we are providing the labels with the data sets. We are training the model. But in unsupervised learning, we are not training the model, and it predicts itself about the input data, the test data, about its type, or the result which we want to know based on the features of analyzing the features of the already feeded data. So these are the main differences. In supervised learning, we are using classification technique and classifies labeled data. And clustering, in unsupervised, we are using clustering, finds pattern and grouping from unlabeled data. We are using regression technique in supervised learning, in which we predict trend using previous labeled data. Then we have a highs in unsupervised learning. We have few evaluation methods than supervised learning, and in supervised learning we have more evaluation methods than unsupervised learning. And in supervised learning we have controlled environment because we are labeling the data. But in unsupervised learning, because it is it is learning by itself about about the data we are feeding, and I'm predicting the specific test about the data. So it is less controlled environment. So we now discuss about the Python used for machine learning. There are different uh, packages of Python. There is NumPy is used, SciPy, Pandas, and there are different libraries and modules are used for this for machine learning. And then Scikit. So there are different features of every package. So then machine learning application, real-time chatbots are there. Chatbots are one of the foremost forms of automation. Okay, then we have uh, machine learning and natural language processing, which are another part of AI technology body, enable chatbots to be more productive and more interactive. Then we have some remarkable examples are Alexa, Google Assistant, Siri, the Watson Assistant. Then we have chat platforms on the riders request service. Then decision support systems are there. AI decision making speeds up the process. Okay, and AI can operate at incredible speeds and see data in always humans would take years to analyze in a matter of minutes. Okay, so these are all the points we have already discussed as well. Okay, so customer recommendation engines, which recommends the users for specific their about based on their likeness and dislikeness, and the recommendation engines are used by Amazon, Walmart, Netflix, and YouTube. Then we have customer churn modeling, used by mostly banking sector as well. Okay, then this business churn modeling is used by Wall Street Journal, Bloomberg News, the New York Times, Spotify, IPO, Amazon, Netflix, and Salesforce and Adobe. Then we have dynamic demand pricing strategies, which are used in businesses and based on the forecasting. Example of business using demand pricing is Bolt, Uber. Then we have customer segmentation and market research. We have different customer segmentation. We make customer segmentation on this in this model. Then we have fraud detection, the ability of machine learning to decipher patterns and to immediately detect anomalies and manifest also those trends. Industry using ML for fraud detection are retail, gaming, travel, financial services. Then we are improving improving cybersecurity by checking whether the specific application is malicious or not. We can use supervised and unsupervised model for this. Then now we'll discuss about the deep learning. Deep learning is a machine learning and artificial intelligence that intimates the humans can gain certain types of knowledge. Deep learning is important elements of data science, which includes statistics and predictive modeling. Deep learning utilizes both structured and unstructured data for training. Practical examples of deep learning are virtual assistants, vision and driverless cars, money laundering, and face recognition. Deep learning is a part of broader family of machine learning methods used on artificial neural networks with representing learning. For example, here in machine learning, there's a classification technique based on the feature. Yes, artificial intelligence is also used in sim solutions as well. For because sim solution is used, is a question. Sim solution is used for taking the logs and making and correlating it and making the decision. Okay, so Source is a platform which is used with it with the sim. Okay, like here in traditional machine learning is we are providing the tweet to then the feature engineering and classification, but the neural network will itself learn about the feed and then uh, predict about for example, this a tweet where there is offense or about. So a neural network basically it was drawn by Santiago Ramon back in 1899 based on what he saw after placing a pigeon's brain under the microscope. So this is the basically structure of a neuron of a pigeon. So basically this is a neuron, okay, which is a soma, is a nucleus, and then is dendrites, which are connected with the other neurons. Then then we have axon, okay, and this is a neural structure. So then we have a terminal button here, and this terminal button is connected with the other neurons as well. So neuron activates give its input to the other neuron, which is it gives its output to the other neuron, which will be the input of its uh, like this is a basically artificial neuron. We have a dendrites, we have the inputs, and this is a nucleosoma. We have axon, which is the output. And so this output will become the input of the other neurons. Like here, we have the in neural network we have input layer, and we have hidden layer, and we have the output layer. So three main topics related with the artificial neural networks are forward propagation, backward propagation, and activation functions. So forward propagation is that we are giving inputs and then we are giving weight and some bias value, and then this uh, neuron will give us the output, and this output will become the input of the other neuron. So and we are using different functions like sigmoid function. And sigmoid function is activation function. Activation function is required for activating the other neuron. And this is just mathematical calculations which are calculate will be which will be carried on the this artificial neural network. So this is not our topic to go in deep. So just I'm showing that how input of one neuron will be the output of the output of one neuron will be the input of the other neuron and so on. These are the example of two neurons. And the back propagation is used basically for tuning the output or the expected output of a neural network. Then we have back propagation algorithms, which basically is used for eliminating the errors. Okay, and in this way, why it is called back propagation, because it will again tune the values of this, for example, weight and bias values, so that we will get the expected output. So complete training of the algorithm and slice the weights and the biases. Alternatively, repeat the following steps. Calculate the network output using forward propagation, calculate error between ground truth and estimated or predicted output, then update it. Weights of biases through back propagation, then repeat the both three steps. Because for training algorithms to tune the values, there are iterations. Then there's a vanish ingredient, which is basically a drawback of this sigmoid function, which is an activation function. So in vanishing gradient, these hidden layers are very slow to learn, and the outer layer are learn well. So this is the basically the drawback. The types of execution functions are binary step function, linear function, sigmoid function, hyperbolic tangent function, ReLU function, leaky ReLU, and softmax function. So most used functions are ReLU function. So this function have also this vanished gradient problem. This hyperbolic tangent function also have the vanishing degradation problem. So we are vanishing gradient problem. So to overcome, we have the ReLU function, which is nowadays mostly used. So we have the pros and cons of activation functions. The sigmoid and hyperbolic tangent functions are avoided in many applications nowadays due to vanishing gradient problem. The ReLU function is the one which is used nowadays in deep learning. So we'll discuss about the deep learning applications. This is a color illustration. For example, we have this picture, and due to the deep learning model, it gives the color to this picture and make it live. Then we have this automatic handwriting generation. This is another application uh, in which we will give some text, and then we will give the option how our handwriting will be there. So the system will give us the handwriting, human handwriting, or we can give it a random style option so that it will give us the random handwritings. Then the other applications are automatic machine translation, automatic adding sounds to silent movies, object classification, injection images, and then self-driving cars. Then deep learning and smart cities. So deep learning is highly used in the smart cities. Okay, recent advancements, computer vision such as edge AI and deep learning combine AI vision with the IoT and is used in smart cities. So now we will discuss about the due to computer vision. We can have different applications with the deep learning. Okay, for example, we'll discuss uh, now the edge computing. Edge computing is basically in edge computing we have a device at the customer end, or we can say this is the end device, and all the processing is done at the with that device. Like we have a camera, all the processing of the its recording is processed over there, and then it is not sent to the cloud. So this uh, uh, make us processing easy. Now we have here camera, and we have the AIT edge device. All the processing is done here, and then it give us the alert. Now we will discuss some uh, application of smart cities. The perimeter monitoring and person detection, then detect violent dangerous situations, action recognition by vandalism, safety and compliance control inspection, suicide prevention in public places, crowd disaster avoidance application, protection and critical infrastructure in smart cities. Then we have AI-based automated weapon detection reporting. Then we have COVID-19 pandemic measures for smart cities, social distancing monitoring in public places, automated mask detection, hygiene compliance control, healthcare monitoring to minimize physical contact, traffic and infrastructure monitoring, smart city monitoring traffic rules violation and roadside surveillance, and packet lot occupying detection. So these are are the one. First of all, perimeter monitoring and person detection. Here, the camera use of camera, we will monitor a person, any intruder. Then we have a crowd disaster awareness. Here, for example, for example, we see when there are a lot of crowds, then we can detect that uh, and avoid and may take the measures to avoid the crowd. Then we have crowd disaster awareness technique. Then we have protection in critical infrastructure in smart cities. So there are a lot of like here, we can use the computer vision with deep learning to detect some suspicious things at a cloud in a public place. Then we have AI-based automated weapon detection. Okay, and deep learning is used. And then we have COVID-19 pandemic measures. Uh, Okay, and you can use social deep learning for social distancing between public places, as you can see in the picture. Then we have automated mass detection. Then we have hygiene compliance control with deep learning, like health care monitoring and to physical contact. Then we have smart city traffic monitoring. Can traffic We can use deep learning for traffic rule violation detection. Then we can use a sort road surveillance application. Then parking lot gang detections. Then sustainability and happiness shaping of future smart cities. This is a report made by on 3rd March 2021 by Mastercard and the Bay Expo. Then okay, there are some challenges, but uh, main thing is that this is uh, AI is giving more benefits as compared to as drawbacks. So this is a summary, of course. We have learned artificial intelligence application, machine learning, and its application, deep learning, its application, deep learning application for smart cities, the future of smart cities. Now we have a question and answer session. Okay, so any solution is used for, and if any name of the solution for anomaly detection, as mentioned in the credit card, there are a lot of solutions. We have already discussed. Okay, for the anomaly detection, we have the machine learning techniques which can tackle this fraud detection technique. So then, okay, I think we have already addressed all the questions. So if any you have any questions, so AI, AI is a vast field. So we can use it for our problems and make the life happy and easy. So, like in smart cities, now people are preferring smart cities due to the COVID-19 pandemic and all the other pandemic situations. Now people want that the most precautions, and then the most precautions can be given in smart cities. And smart cities are using this deep learning techniques and this AI, artificial intelligence, so to facilitate the people so that they will be safe and sound, and all their processes, all their working become automated. So we have a lot of applications and of AI, and AI is evolving day by day. So, uh, so I will, say that artificial intelligence is the most advanced technology now in the current era, and it will also play an important role in our lives. So I will now. I think that we have no questions. Again, I will thanks to TDRA for giving this opportunity for delivering this session on artificial essentials. And thanks to all the participants for participating in this session.